My name is Eugenio Marletti. I was born here in Turin, and now I live and work in Berlin at Clue. Today I'm going to talk to you about sync, but first let me tell you a story. So according to Google, in 2014, the fastest growing app category was health and fitness. And in the category, the most popular type of app is running apps, not surprisingly. Well, the second most popular type of app is, can you guess? It's period trackers. Women are as geeky as men are. They want to track what's happening to their bodies in order to gain control over it, which is both useful and empowering. There's a huge need and market for it. Even though I know maybe you're not designers, but can you spot the subtle design trend among all of these? They're very, very pink. So that's what we do at Clue, but we play it differently. We don't have a single pink pixel, and quite the opposite. We employ a very neutral design, so much that many of our users are actually men tracking their partners. And I think the best way to describe how our app feels is from quoting an actual user review. An app doesn't fart rainbows. Okay, so anyway, since we released the first version, first for iOS and then for Android, the #1 most requested feature by all of our users has always been data syncing and sharing. That means they want to have a place online where they can back up the data, but not just have it stay there. They want the data to seamlessly go across all their devices, even cross-platform, like from an iPad to an Android phone. They want that, and they want the ability to share the data with other people. It could be a partner, a doctor, friends, which apparently is customary in some cultures. Syncing and sharing is something that is almost expected today in many apps. And so we said, sure, we're a bunch of smart people, why not? How hard can it be, right? We had some requirements that we imposed on ourselves. It would have to be a cross-platform solution for obvious reasons, as we have two apps. We didn't want to reinvent the wheel, because we are lazy and we don't want to do it. So again, we want to do as little as possible, as this is not our core business. Like, we're not Dropbox. Dropbox bases its entire business on syncing. We didn't want to spend years making it perfect. We just wanted a feature, okay? And last but not least, we wanted it open source and actively developed to avoid being locked in a solution that then we couldn't escape from. That being said, we tried to scope what would happen. So this is what it is right now. We have a local service running on the app. There's no syncing whatsoever. And we said, okay, let's think about the simplest case we can imagine. And that would be a persistent connection to a single server. Imagine our website, like the simplest website you can ever imagine, okay? And then we say, okay, we have almost 1 million active users. So first of all, it would have to be multiple servers, which is an entire class of problem on its own, but we don't care. We just do the client, so whatever. Just to keep in mind. Then it gets interesting, because users, again, they want multiple devices, and they want the data to sync between that. Now, if we imagine the connection is persistent, then that's not so bad. Imagine accessing Facebook from different devices, but still always as a website, always online. If that's the case, then the service can manage all the data. The client might not even have a copy of it, or if it has it, if you can only view it, that's not so bad. As soon as they start modifying it, that gets tricky, especially when the connection is not persistent. Mobile devices are by definition flaky. They are not always connected, and even when they are connected, the connection might drop unexpectedly, so you cannot assume that, absolutely. So that's the real problem. Having multiple copies of the data all around, they might never be online at the same time. They might get modified in unpredictable ways. How do you have this information flow between all the nodes and somehow not get crazy? Plus, users also want the data to go between them, which is like an extra layer, even though, in my opinion, it's more of an extension to the problem. But yeah, anyway, something to keep in mind, right? So we understood that this was the problem. We had a clear scope in mind, and it was such a common problem that we thought, there would be ready solutions, right? I mean, everybody wants to do this. And they're not. It's not so easy. At some point, we got so desperate that we were all like, holy shit, this is really hard. Yeah, so again, we started researching, and we considered very briefly building our own solution, which we discarded immediately. We considered wrapping Git somehow to manage the data. Again, finally, we found a viable solution, not without pain points. And this is how we went from holy shit to holy sink, in case you didn't get the joke the first time. Yeah, so it all starts with a company called Couchbase. They make a NoSQL document-based database. They make the full stack, so it means the server side and the client side. And the client, that's what's interesting for us, it's called Couchbase Lite. Embedded NoSQL database that speaks the CouchDB protocol and is designed for mobile, which is essential. So it solves the problem for us. It's free, it's open source, it's actively maintained by people paid full-time to do it, which is great. It's cross-platform, it runs on Android, it runs on iOS, it runs on pure Java, so probably your microwave can run it. The cons is that it's an entire new way to think about data. It's very, very different. And it introduces, not only on the client side, but on the server side, it's a new stack. So you really have to consider it. It's not for everyone, but for us, it really made a difference. It enabled us to ship the feature the way we wanted it. Brief mention, CouchDB. I don't know if you know it. It's made from Apache, and it's the same. It's a NoSQL database. What's interesting for us is that it's kind of a protocol now. It's like almost official. And the fact that we can speak the same protocol means we're not locking in anywhere. We can choose the vendor for the database. We can easily migrate, and it's much more transparent that way. So also, the logo is a lazy person. We said, sounds like a perfect fit. So NoSQL, again, the best way I can describe it is that it's not SQL. It's really like, get everything you know about SQL and just throw it away. It's another thing. Many people have this assumption that it's somehow better. It's not, it's different. And depending on your need, it might be what you need, or it might absolutely not what you need. In my humble opinion, I think if you're good with NoSQL, even though you might have some trouble mapping your data in tables and such, but if you can do it, just go with it, because it's probably better. It's better understood, it's more mature. But again, doing this thing that way, it might be troublesome. So, a NoSQL database has no schema. Imagine that you have a bunch of JSON objects, okay? You just put data inside. It's like key-value pairs, okay? You can do whatever you want with it. It's great, except it means that data consistency is now your responsibility. And that's not a small task to do. Also, there's a concept called denormalizing the data. In SQL, every time you have redundant data, you extract it in a separate table. Here's just the opposite. Like, keep the data as close as possible to all the relevant parts. It's very important because you might not have the same consistency. Like, SQL is atomic. Whatever changes you do, you're sure that they happen at the same time, okay? This is not the case. So here it's eventually consistent. It means sometime in the future, maybe, if you're lucky, data will be in the same state that you believe it is, but you might not assume that at all times. So keep the data as close as you can. Obviously, there's a limit, because if you put everything inside a single document and you sync the whole thing every time, it defeats the purpose. So there's a technical term. You denormalize it until it hurts, which means, again, you need to find a balance. There's no silver bullet. You just need to experiment and find what works for you for your data model. Also, there's something called views. So SQL is great for querying data. The way you can dynamically specify conditions to query the data is amazing. And you don't have it here. You have something called views, which we'll talk about later. It's based on a concept called MapReduce, which we'll see what it is. So again, imagine the database as simply an array of JSON objects. That's the best way to describe it. And it's literally what it is. Plus something called attachments, which are blobs of data. Like, imagine files. You wouldn't put an entire file like base64 encode inside a JSON document. You just keep it separated and link it to the document. But I won't even talk about that. It's too long. So that's what a document looks like. Pretty simple. It has your properties, so key values, as many as you want. Call them whatever you want. Put inside whatever you want. It has an ID, which is unique per each document. Oh, also a note, the underscore properties, they're reserved for system, so never start your properties with underscore. ID is unique. It means that if you try to somehow create two documents with the same ID, you'll just end up modifying the same document, which is great for consistency, because that's probably the only way you can enforce modifications to happen in the same way. And then, and that's interesting, you have a revision. A revision is a very cool concept. So the first number is the generation of the document. I mean, the first time it's going to be 1, and then every time you add new revisions, you're going to have new generations. And what's after the generation is a checksum of the entire document. It means if you have the same properties and the same ID, the checksum will always be the same. Which means if you have different nodes and you do exactly the same modification on both nodes, the revisions are going to be exactly the same. It's like, there's no conflict in that case, okay? And that's exactly what we want. So how do you modify the data? Each revision is immutable. You cannot change a revision. It's not going to happen. The way you do it is that you actually add a new revision. Again, the generation becomes 2, the checksum changes, and whatever value you changed. But then imagine you have 2 different devices, okay? So you created the first document, you synced it on your tablet and your smartphone, to make an example. On your smartphone, you change the value in one way, and on your tablet, you change it in another way. So what happens? There is a conflict. Now, the name is misleading. Conflicts are not bad. Quite the opposite. Conflicts are your friends, and they are what makes things happen, pretty much. The best definition I could find is a bit long, but it really captures the essence. They're not error conditions. They're the result of your infrastructure, allowing the same dataset to be modified across disconnected systems. The introduction of such conflicts in such a topology is the expected behavior, and their programmatic resolution is a core piece of the application logic. And that's exactly what they are. Like, they are what makes it possible, okay? So let's get back to our documents. Again, we have to, how do we solve this conflict? So again, you just append a new revision, which is a special revision. In this case, it's called a tombstone revision. It has the underscore deleted property. That means whatever tree you create of revisions, every time the leaf of that branch is a tombstone revision, it means the entire branch is dead, pretty much. And so whatever is left is the winning revision. So in this case, we had that conflict, and we solved it by appending the tombstone revision. Something that is interesting is that you might think that the history is preserved. It's not. So you might at all times know the ID and revision ID of all the past documents, revisions, sorry. But you will not get the properties of it. Otherwise, your database will become so big, because every time you make a change, you essentially keep a copy of the data, and that's definitely not ideal. So every time you compact the database, or the server might do it for you, you will lose the past data. So you'll only have the leaf nodes. So all the conflicts will always have the data. Otherwise, you might not be able to resolve the conflicts. And of course, the winning revision will always have the data. So, but this is not made to create a sort of like Wikipedia effect. If you want to keep the history, you have to do it in your data model. This is not made for that. Just keep it in mind. It's important. So this is how document works. And next is replication. So, okay, you make these amazing changes. How do you replicate the changes? It's as simple as pushing the changes or pulling the changes. It's really that easy. The beauty of it is that the system, the Couchbase Lite, takes care of it for you. So you simply say start the replication and pretty much forget about it. All the same rules apply to when doing the syncing. Like, yes, you can achieve real time if you want, and literally sync every single change every time, and I don't know, have push notifications every time something changes. You can do that. You probably don't need to, because you're going to have a lot of requests on your server, and also your client are going to like drain the battery and everything. But still, you can do it if you need it. It really depends on your use case. So let's recap. We have a distributed system, right, based on versioning, where conflicts are solved by appending a new revision. Oh, which, by the way, you can either, like, you kill, let's say, a branch of the tree, and you have a winning revision. You might as well add a new revision, which merges the data between the two revisions that were conflicting, 2 or more. They could be 100, I don't know. So you can create a merge if you want, and data is pulled and pushed. Does that sound familiar in any way? It's pretty much like Git. It's the same way. Like, you keep a copy of the data, you pull and push it around, you append new revisions. That's pretty much Git. Which, if you like, it's great, and if you don't, just deal with Git. Okay. If you want, I have a background you can download later. Anyway, so queries. So that's the interesting part. Again, SQL makes it so easy to query data. It's like trivial. Even though when you actually write a query, you go crazy because SQL is a terrible language, but it really works. It's very effective. In NoSQL queries, you just don't. There's no queries. There's 3 ways to query for documents. The first way is you get it by ID, which might seem little, but trust me, if you model your data correctly, querying by ID is actually very effective, because you might get exactly what you need. You can query a view, we'll see later what that means, or you can just iterate through all the documents. I mean, sometimes that's what you need to do. There's no escaping it. Keep in mind it's also very fast to read the documents, but yeah, anyway. So views. Views are based on this map reduce concept. I will only talk about map and briefly mention reduce. Mapping is a local function, so it only runs on the device. The server doesn't know about it, doesn't even care. Every time any document is added or updated, it goes through your mapped functions, and you have the ability to emit key value pairs to somehow index or pre-analyze your data depending on what you need. This is the only snippet of code, I promise, but it makes it so easy to understand what's happening. Like, database, you create a view, and then on the view you set a map. And then for this map function, you get each document that is, again, added or updated, and you have this emitter object. And then what you do is entirely up to you. For example, in this case, it's trivial. From the document, they get a property called phones, which is a list of strings. And then for each phone number, you emit whatever you want. In this case, it's key value, so it's the phone number and whatever name is associated with the document, right? You can do crazy things with it. Like, for example, we have an algorithm running every time the data changes, but the algorithm only cares about certain types of data. So whenever any piece of data changes, it goes through a specific map function, and that function says, does the algorithm care about this piece of data? Yes. If yes, then how? And it already extracts all the meaning it needs and saves it for later. It's like a small piece of the algorithm input. And then every time a small piece changes, it just aggregates all those small bits together in one coherent input and feeds it to the algorithm. And it's super effective and really fast. But again, it's not, you'll see that later how we query it. So also, worth to mention, this number here is the version. Because again, these are entirely local. If somehow your data model changes, then you will want to remap whatever you mapped before. So you simply change the number, and it will rerun this function on all the documents in the database, so you have like an updated index that makes sense for your data model. So this is an example of what would happen. You have this key number, key values, right? The numbers and the names. You can either not emit anything, or you can emit as many keys and values as you want. You might even not have a value. Like, it's entirely up to you. It's just a tool you can use. What's interesting is that the ordering of the keys is very predictable. And the ordering is what makes it special, because then when you query, you can only query a range of keys, and you do it by saying, what's the starting key I want to query from and the end key I want to query from. So this is the ordering. Null is first, then we have booleans, numbers, strings, arrays which are sorted item by item, and that's a nice trick that we'll see later. And then we have maps and dictionaries, which you should never use them, because again, they are sorted item by item, but in JSON you cannot enforce the ordering of items, which means the ordering of this one will always be unpredictable. So the only use case you can have of it is having an empty dictionary, which will always be sorted last, whatever you have. Again, 3 things to remember. Null is first, maps are last, and arrays are sorted item by item. That's all you need to take from this. Arrays are important because, let me make an example. So these are keys. Each line is one key, and each key is an array, okay? So let's say, I don't know, we discovered an alien artifact, and it blinks with some colored light every day, or multiple times a day, and you somehow want to track it. Why not? So, you see? And then we say, we want to query by a specific day. So if we were just to say the day, it wouldn't work, because it would be like a single string, and it would be before all the arrays, so it would not work. So let's say we want to query this range here, right? So we said null is first, and arrays are ordered item by item. So if we do this is an array, item by item. The second item in this case is null, so it will always gonna be before the range we need, right? And what can we use as the end key? We can use the same with an empty dictionary. So that way, we're gonna query exactly the range we need. So what happens then if we say we want to query by day and color? Then we simply use the same key for both start and end, and we could say like day 3 blue, and end key day 3 blue, and it will query just the first 2 lines, for example, right? So again, it's weird, and it takes some time to getting used to, and you really need to make sure that you model your data and your views in a specific way. So it's a lot of pre-thinking about the data. SQL is more like create the data and then think about it later. This is just the opposite. Yeah, I mean, if you do it correctly, it's very powerful. Then, you shouldn't care about the server side, but there's something that you need to know. Backend trouble. So it's not uncommon for SQL to actually have users connect to the database directly, because it takes care of authentication, and that's fine. Except it doesn't happen here. There's no concept of authentication whatsoever. So what you need to do is to have a proxy between your database and your users at all times. Some vendors do it for you. Couchbase does it for you. So you might not even think about it. For what we went with, we had to create our own proxy, and it wasn't painless, but we did it. It's also cool because that way we have full control over how it works, and for the sharing part, it's as simple. Oh, wait, before that. When you do pull and push replications, you can actually attach a filter to them. So it's a function that runs on all the data that goes through and selects if it goes through or not. For sharing, we can simply have like the user on the right has given access to the user on the left on a subset of its data. So the user on the left just asks for all the data of the user on the right, and the proxy will attach the filter. So it will go through the database directly with the filter, and it will only get back what is allowed to see, which is a very elegant solution, and it just uses the system to make it work. And so that way, the sharing part is trivial. Like, it's really easy compared to everything else, right? And yeah, it's a nice extra. Some tips and tricks that we found, like pain points that I would like you to know if you ever want to do this before you go through it. Don't be scared of metadata. You can add whatever you want in your documents. For example, we decided to add a created at and updated at property. We use the $sign symbol just to make it apparent that it's metadata, but it's just a symbol. You can do whatever you want. That way, not only we have very cool analytics about exactly when the data happened, but whenever we have conflicts, we decide to solve them based on the timestamp, which is tricky because the timestamp is local, yes. At the beginning, we went for a very complex UI solution where the user will be prompted to see all the conflicts and then somehow choose how to merge them, and it was just not working. The user, they don't care, and they really just wanted the simple way, so we just use the local timestamp. they might still fuck up their data. So we're wondering about creating a snapshot solution, something like every day it takes a snapshot of the user data. If somehow they just mess it up, they can go back one day or something, which is good enough for us. Again, it depends on what you want to do. EDs are awesome. I can stress this enough. They're pretty much the only way you have to enforce some sort of consistency. For example, at the very beginning, we went for a complex data model. The IDs were just randomly generated, and we couldn't make it so that, for example, we have measurements. One of them is a pill measurement, and you're only allowed to have a single pill measurement per day. So in order to make it so that it was only one per day, we went through crazy length and some crazy code to make it fit and so that it wouldn't duplicate the document type. So now we said we just use the ID as the enforcing constraint. Every ID for us starts with a type. For example, some types are just that, like we have user averages, which is something they choose at the beginning when they use the app. There's one document called like this, and only one. And if on any device you try to write to this document, you're all gonna write to the same document. There's no way you can do it differently. So every time any device writes to this one, they will create a conflict potentially, or just updated data, and it will sync seamlessly across all devices. And that's it. It's enforced. Magic. Then most of our types actually have a day attached. So then we'd use the pipe symbol to see when the type ends. And then whatever is after the pipe, it's up to the type to decide. For example, we have this peel value, and this is an actual ID of a document, which means peel measurement in that day, there can only be one that way, okay? And then, of course, you can add like values. For example, we have tags, which are one by day. And yes, you can use emojis in IDs. You can use any Unicode character. For example, it doesn't make sense for us to have multiple tags with the same text in a single day, so that way we enforce that user couldn't do that. Or just use values. For example, we have the favorite tag in a list, like a sort of a bookmark, that it gets synced across devices, and it is just without the date. It's like a tag, but without the date. Something else, you should be wary of deletion. So at some point, imagine you have this document, right? You have an ID, just cropped for simplicity. You have a value, which is our custom property, okay? And you have an updated at, let's say, T0, okay? So what happens? You have two documents, let's say on two different devices, to make it simple. On one value, you change the value, we have this concept of removing measurements. So imagine it's like a radio box. You can either check one of the options or uncheck any option, pretty much. So the way we first went with it was like, let's just delete the document, right? Except if you do that, what happens is that you're actually gonna kill this branch. And so this is gonna win automatically. You didn't create a conflict, you just said this wins, which is not what you want. So instead of using a tombstone revision, you should use your custom property. We have a property called removed, which actually creates a conflict, which is what we want in this case. So now we can say, wait, what's the timestamp? Okay, that's older, we want that. So we'll add a tombstone revision to this one, actually, okay? Some gotchas for Android. So to trust your data is good, not to trust is better. If you remember the snippet of code at the beginning, there was an example. You just took the data out of the document and blindly casted it to something else. Don't do that. Like, it could be anything inside. It could be your error on the client side. Also, keep in mind, if you have cross-platform, it could be that the iOS code somehow is different, even slightly so, and introduces data that might crash your app if you're not careful. So be very careful. That's the bad part about no schema. But still, it's not so bad. The way we do it is we are optimistic about it. So we just go with it thinking it's okay and catch any exceptions that might arise. It's the best way generally, also because, I mean, yeah, as a general use case, it works better. Obviously, find the right time to start replications because that, like, the same rules apply. Use a sync adapter if you can, or whatever. Just be a good citizen for your users. When saving objects, they get converted to JSON. So keep in mind, whatever object you have is going to be formatted as pure JSON. So that's something to keep in mind if you have complex types. Try, if you can, not to nest them too much. Otherwise, every nesting will create a hash map with blah, 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 more objects and more things. We're just flattening as much as we can, and it works for us. And then, of course, when reading, the JSON will be part as a map of string and objects. It's using JSON behind the scenes, which means this is always going to be a hash map, unless you add your custom deserializer, which we're trying to do, but then the system is expecting a hash map sometimes. I don't know why they do that. So yeah, one thing we did, a little trick, was we modified the bytecode of the library in order not to create a fork. And we make it so that we can cache values directly on the document to avoid not parsing them every time. But it's just a trick. And yeah, you can do whatever you want, but pretty much. Then we have models. Models are amazing. It's like an ORM directly in the library. You can add annotations, and it will create a structure for it, which is the closest thing you have to a schema. And they're iOS only, obviously. Yeah, terrible, terrible. I hope they're going to come sooner or later, because, yeah, we really need them. Anyway, that's it for me. You can find the slides, not animated, I'm sorry, on this link. And you can stalk me at Working Kills. And that's it. We have exactly 5 minutes for questions. That's amazing. Thank you.